Hello and welcome to Advanced Mathematics 1, Unit 2, Part 1, Solving Multi-Step Equations. By the end of today's lesson, you'll be able to do the following things. You'll be able to solve multi-step linear equations using inverse operations, and you'll be able to identify equations with no solution and those with infinitely many solutions. So the main concept of today's lesson is basically the procedure for how to solve these equations. First, you're going to simplify both sides of the equation if necessary. It may not be necessary to simplify one of the sides. One could already be simplified, but basically what that involves is getting it so that you're combining like terms, that there's only one letter at most and one number on each side of the equation. So the right side has a letter and a number. Maybe the left side has a letter and a number. It might only have a number, but you get the idea. Then you're going to move the variables to one side of the equation and the number terms to the other side of the equation. You do that through inverse operations with both the variables and the numbers. It doesn't really matter which order you do that in. I generally do the variables first and then the numbers second. And then you're going to solve the resulting equation, which is generally going to be undoing the multiplication or division that's left. All right. Moving variables and numbers from one side of the equation to the other is done, like I said, with inverse operations. So if it was like 6x plus 10 equals something, you would undo the plus 10 by minusing the 10. If you had 6x plus 10 equals, let's say 10x, and you want to move the 6x, you'd have to subtract the 6x from the first side in order to get the 6x off of that side. You can also remember the following, that when things change sides, they change signs. So if something is positive on the right side of the equation, when we move it to the left side, it will be negative. So that's another way to kind of remember how to do that. All right, moving into our examples. Our first equation says 3 times the quantity x plus 1 plus 6 equals negative 9. So basically only the left side of the equation needs to be simplified because there's a distribution and addition over there. So I'm going to simplify my distribution first. So I'm going to multiply that 3 through both of those terms. So I have 3x plus 3 times 1, which is 3, plus 6 equals negative 9. Now I still have more than one number term over here, so I'm going to combine my like terms over here. So 3x, 3 plus 6 is 9. And then I'm going to solve this as a simple equation by undoing my operations. So I'm going to subtract 9 from both sides. And I get 3x. Negative 9 and negative 9 is negative 18 combined together. And then I'm going to undo my multiplication by dividing both sides by 3. And I get x equals negative 6. Final answer. Now you can always go back and check your answer by putting the negative 6 in here. So you have negative 6 plus 1 is negative 5 times 3 is negative 15 plus 6 is negative 9. So you should always do that. You can use a calculator, obviously. Just making sure that you didn't make any silly mistakes along the way. All right, in example 2, we have an equation that has distributions on both sides. We have negative 9 times t minus 2 equals 4 times t minus 15. So I'm going to start by simplifying both sides of the equation by distributing both of these things through. So negative 9 times t, negative 9 times negative 2 is positive 18. And then on the other side, I have 4 times t. And then 4 times negative 15 is, I think, 60. Let me just double check. Obviously negative. What? I said 4 times 15. Okay, I'm okay. Minus 60. Yes, that was correct. Sometimes. All right. Now I have letters and numbers on both sides. So I want all the letters on one side and all the numbers to the other. Now, some people are fanatics about keeping the letters on the left side. I like to keep the letters positive. So I'm actually going to move this 9t to the other side by adding the 9t to the other side. And that gives me 18 equals 9 plus 4 is 13, t minus 60. Now I have a normal equation, so I'm going to add 60 to both sides. $18 plus 60 is 78, yep. And then dividing by 13. So divide both sides by 13, and I get 6 equals t. Final answer. Again, I would go back and just plug it in your calculator. So you have negative 9 times 6 minus 2. And if you do that side, you get negative 36. And then 4 times 6 minus 15 is negative 36. So that checked out. All right, example 3, we've got a lot more going on here on both the left and the right. So I want to start with simplifying my left and my right side of my equation. I'm going to start by simplifying this thing right here. So negative 2 to the third power is negative 8. I have negative x minus 4. And then over here I have the absolute value of negative 2 is 2. The negative stays out front, so I have negative 2. And then I have negative 3 squared. 3 squared is 9. And then on this side I can go ahead and start distributing. Don't have to, but it might as well. So negative, I could wait another step. It doesn't really matter. Negative 2 times x is negative 2x, and negative 2 times negative 4 is positive 8. All right, now I can distribute here. So negative 8 times negative x is positive 8x. Negative 2 times negative 8 times negative 4 is positive 32. I can go ahead and combine these right now. I could wait till later, but it doesn't matter. So negative 2 minus 9 is negative 11. And then on the other side, I'll go ahead and combine my x terms over here. So I have negative 2x and negative x makes negative 3x. All right, now I want to combine my number terms over here. So 8x, 32 minus 11 is 21. Oops, that's an x. Then I will go ahead and move my letter terms. So this time I'm going to move them to the left because there's more on the left. So I'll add 3x to both sides. That gives me 11x plus 21 equals 8. So I want to now subtract my 21 from both sides. And I get 11x equals 8 minus 21 is negative 13. And then my final answer, I would divide both sides by 11. So it's negative 13 over 11. Final answer. Again, you should go back and check it. Obviously, you can't check everything because you probably don't have an absolute value on your computer or on your calculator. So you would have to at least have done this part of it, the minus 2 ahead of time. But other than that, you can check everything else. So you should be good to go. All right. All right, as we move into an example 4, we are moving into special cases. And in a special case, what happens is the variables drop out, leaving a statement that is either true or false. So, for example, if you end up with a true statement like something like 10 equals 10, then the solution to the original equation is all real numbers, because any number you put in there will work. If you end up with a false statement like 5 equals 2, then there's no solution to the original equation because nothing will work. So let's look at example 4 and see what happens here. So I'm going to start by distributing on the left side. So I have negative 2 times 4 is negative 8y. Negative 2 times 1 is negative 2. Now you might be able to already see what's going to happen here, but I'm going to go through it anyway. I'm going to go ahead and move my letters to the left. When I do that, the y's drop out from this side, leaving negative 2, and the y's drop out from this side, leaving negative 2. So this is a true statement. Negative 2 is equal to negative true. That means that any number in the world will work. So you can write all real numbers. But if you like shorthand, you can just write the symbol for all real numbers, and that's fine as well. And that's it. That's all for our lesson today. So I will see you next time. Goodbye.